Today, lesson 23B. So far in this unit, we've talked about ratios, different ways of writing ratios, what we usually do when we have a ratio. We also talked about rates and unit rates. Well, today we talk about something that we refer to as a proportion, and a proportion is made up of ratios. But we'll define exactly what a proportion is a little bit later in the lesson. So today we're going to be solving proportions and word problems involving proportions and explaining in words how we go about doing that. And then, of course, our usual why am I learning this? A little bit of background knowledge for what we've done so far. We took fractions or different wordings of a ratio. We talked about how to simplify them. Remember, since a ratio involves two numbers, we don't want to write a fraction that's improper as a mixed number. We leave it as two numbers. That's the most common way of writing a ratio as a fraction, but sometimes we want to write it with a colon instead. And here was another one that we had done in there in one of the previous lessons. And remember, typically with ratios, we don't want the units, which is why I no longer have any units there. So 2 over 3 or 2 colon 3. All right. Several times this year, I've referred to equivalent fractions or equivalent ratios. When we're talking about ratios that are equivalent, we're talking about ratios that are of equal value. For example, and here's where you need to fill some things in. 2/3 is equivalent to 4/6, which is also equivalent to 6 over 9, which is also equivalent to 8 over 12. Why are all three of these equivalent to 2/3? Why? Really?
Because they can be divided by the same number.
They can be each divided by the same number. I don't know what you mean by that.
They all can be divided to equal to.
They can all be simplified or reduced, right? To be equal to 2 over 3. 4/6 reduces to 2/3. 6 over 9 reduces or simplifies to 2/3. Same thing with 8 over 12. That's what makes them all equivalent to each other, because they all represent essentially the same number or have the same value. That's what equivalent ratios are all about. Same thing here. Fill in these equivalent ratios. 28 over 16, 21 over 12, 14 over 8, they all three simplify to 7 over 4. That's what makes them equivalent. We're going to come back to this idea of equivalence throughout this entire lesson. But you need to understand when I talk about equivalent ratios, what it is that I'm talking about. All right. To determine whether two ratios are equivalent to each other, what we would need to do is to simplify them to see if they are equivalent. This problem is in your notes. I would like you to simplify each of those ratios to see if they are equivalent to each other. I'll give you about 30 seconds. They are equivalent because if we simplify them, first fraction will simplify to 4/5. Second fraction also will simplify to 4/5. So that means 16 over 20 and 20 over 30 are equivalent to each other. All right, so you have 4 problems in your notes. Go ahead and find out whether those ratios are equivalent to one another. I'll give you about a minute and a half to do all 4, and then we'll compare with our shoulder partners. Number 1, we have these two ratios right here. We are trying to figure out, Jermaine, if they are equivalent. Are they equivalent, yes or no?
Yes, they are equivalent.
Okay, good. And the reason is because they both simplify to 2/3. So that means that they are equivalent. Number 2. They're not. 12 over 7 is already simplified, but if we simplify 60 over 34, that simplifies to 30 over 17. Those two ratios are not equivalent to one another. Number 3 looks like this. Are they equivalent?
No.
They are not. 8 colon 11 is the same thing as 8 over 11. 6 colon 9 reduces or simplifies to 2/3. Those two ratios are not equivalent to each other. How about number 4? Number 4 looked like this. Are they equivalent? Yes, they are. Both those ratios or fractions reduce or simplify to 6 over 5, so therefore those two ratios are equivalent to each other. Well, when two ratios are equivalent to each other, there is a name for that, and in your notes you have a blank spot you need to fill in here, and that is, as I mentioned earlier in the lesson, that's what we refer to as a proportion. A proportion is an equality between two ratios. So if we have two ratios that are equivalent to one another, they form a proportion. And so if you look in your notes now, right below where you had to fill in that blank spot, I've retyped up for you 1 through 4. Those are the 4 problems you just did. If two ratios are equivalent, then they form a proportion. Listen to that one more time. If two ratios are equivalent, then they form a proportion. So I want you now to do those 4 problems again. Now you're stating whether they are a proportion or not. Go ahead, I'll give you about 30 seconds. All the work you just did, so 30 seconds is probably about 15 seconds too long. All right, we're about to shoulder partner all 4 of those. Please notice that I have a sentence frame up here. We would use the sentence frame to structure what we want to say for those 4 problems. You would either say the ratios do form a proportion because the ratios are equivalent, or you're going to state with your shoulder partner the ratios do not form a proportion because the ratios are not equivalent. Everybody understand what I mean by that? Yeah. All right, go ahead and go through all 4 with your shoulder partner. So the first one we talked about, they were equivalent, so the ratios do form a proportion because the ratios are equivalent. Here was the second one. We found out that the ratios were not equivalent, so the ratios do not form a proportion because the ratios are not equivalent. Here was number 3. Once again, the ratios were not equivalent, so the ratios did not form a proportion. And number 4, the ratios were equivalent, so that means that they do form a proportion. Well, that leads us now to equations that look like a proportion. Notice that in 5 through 16, you only have the first part. So when I give you these problems, you're going to have to fill in the rest of the equation. So what I'm saying, if you look at number 5, this is the only part that's written down for you. You now need to fill in what the rest of it looks like. Fill in that part right there. So here's what we're trying to do. We're trying to figure out what number or what value we can input for the letter n that would make this a proportion. In other words, so that those ratios are equivalent to each other. Now I'm going to show you 2 different ways of doing this. I don't care which way you do this. One way is by starting with the ratio that is given and to start listing out equivalent ratios to that until you finally get something where the bottom number is 21. So if I multiply the top and bottom of 5/3 by 2, I get 10 over 6. If I go back to 5/3 and I multiply top and bottom by 3, I have 15 over 9. If I go back to 5/3 and multiply top and bottom by 4, I get 20 over 12. If I multiply top and bottom by 5, I get 25 over 15. If I multiply top and bottom by 6, I get 30 over 18. If I multiply top and bottom by 7, I get 35 over 21. And finally, I have an equivalent ratio to 5/3 where I end up with a denominator of 21. That's one way of figuring out what value I need. Another way would be simply, and let me get caught up on the parts that come up here. Another way would be simply trying to figure out what do I have to multiply, because here's what we were given. We were given this, 5 over 3 equals n over 21. What would I have to multiply 3 by to make 21? Just say it, please. 7. And so you could then multiply the top number by the same value, and that would lead you to n being 35. I don't care which method you use, but if you're going to use this method right here, you need to show me what you're doing. Or show me this method. But you have to show me what you're doing. And then the other piece of this is this. This is an equation. A proportion is a special type of equation. So you need to tell me what n equals. So n is equal to 35. So are we clear on what I need to see for work? Yes or no? All right. All right, here's what number 6 looked like. Bushra, what did you get for the value of n? It is n equals 28. Once again, you're trying to figure out what n could be to have or make a proportion, or in other words, equivalent ratios. You could scale up, like I explained in the first problem, or you could show me that you're multiplying top and bottom by 4 to make the 12 over 28. But regardless of that, we should end up with n equals 28. Aiden, number 7.
You would multiply 4 times 5 to get 20.
Yep.
And then on the bottom, you do the same thing. 4
Okay.
times 5,
And n is equal to?
25.
Very good. You could scale it up by creating equivalent ratios, or as Aiden said, you can multiply top and bottom by 5 to get a value of n equals 25. All right, let's go to the back side of the note. Number 8, this is the proportion we start off with. We're trying to figure out what value we could input for n to create equivalent ratios, or in other words, a proportion. You could do this by scaling up. And I'm saying scaling up because the ratio we're given is smaller, not in value, but the numbers are smaller than the ratio that we are given on the right-hand side. So we scale up, or we could just multiply top and bottom by 6, but regardless of that, n is equal to 54. Number 9, same idea. We could scale up, starting at 8 over 7, creating equivalent ratios until we found one that satisfies what we need. Or we could multiply top and bottom by 3, so n is 24 on that one. And then number 10, we could scale up or multiply top and bottom by 7 to get the value of n equals 35, which is what we're looking for. All right, so that's pretty easy. Let's now take a look at number 11. Go ahead and finish off the proportion for number 11. We have 12 over 20 equals 6 over n. Now notice that in this one, the ratio that I'm giving you actually has bigger numbers than the ratio on the right. So here's what you could do. What you need to realize is that there are many ways of writing 12 over 20. One is, if we divided top and bottom by 4 to reduce it, we would end up with 3 over 5. 3 over 5 is the same thing as 12 over 20. All I did was I took 12 over 20 and I reduced it. And I get an equivalent ratio. If you did it that way, you could solve it from here. You can do that because 12 over 20 and 3 over 5 are the same thing. They are equivalent to each other. So you could, I call that the scale down method, because you scale down the original fraction and then you take it to a problem just like the kind that we just talked about, where we could multiply top and bottom by 2 to get n equals 10. But what if you didn't want to scale down? How could you utilize the same strategy that we just did in the previous problems? What could you do?
You could divide.
Ah, yes. We know we have to make the number smaller, so instead we could divide top and bottom by 2 instead of multiplying. 12 divided by 2 is 6. 20 divided by 2 is 10. We still got to n equals 10. And once again, I don't care which method you do this, by scaling down and then scaling back up, or by multiplying or dividing top and bottom number by the same thing. But make sure you show me and make sure you state what the answer to this equation is. Variable equals whatever it happens to be. All right, so let's take a look at number 12. Number 12 looks like this. Once again, you could scale down. You could replace this with all kinds of things. Just as long as you reduce it, it will make the proportion that you're trying to find, or excuse me, the value you're trying to find to make a proportion Much, much easier. Now, I know some of you saw that you could just divide top and bottom by 2, and that's great as long as you can see it, but you could have reduced this 72 over 32 down to 9 over 4. You could have done this and used that instead. It doesn't matter because 9 over 4 is equivalent to 72 over 32. So at that point, you could have multiplied top and bottom by 4. I didn't mean to write divide right there. I meant to write multiply, to see that you're going to get 36. There are many ways of getting to the value that you need. You just need to make sure that you use a strategy that will work for you on every single problem. Number 13 looks like this. Many of you saw that you could divide the top by 6, so you divided the bottom by 6. That's fine. But you could have also used the scale down method and used now 3 over 2 in place of 36 over 24 because they are equivalent to each other, and gone about it in that method. Regardless of that, we should see that we get n equals 4. Number 14. This was the first one where a few of you kind of got stuck. You could have used the scale down method, which is to take 24 over 114 and reduce it down to 4 over 19. So now, if you replace this with this, because they are the same thing, you can get to n much, much faster for some of you. Some of you saw that you could just divide top and bottom by 3. So n is equal to 8 in number 14. Number 15, same methods, scale down, then scale back up, or see that you have to multiply, or you could divide both top and bottom by 2 to get a value of n equals 16. And then number 16, all of the methods we just talked about will work. I'm showing you all of them right here. But regardless, we should get a value of n equals 2. All right. We're going to finish today with word problems. Number 17, it goes like this. A recipe for 26 rolls calls for 5 tablespoons of butter. That first sentence gives us a ratio, much like we talked about in the very first lesson in this unit. So let's write that down. 26 rolls per 5 tablespoons. And I spelled it incorrectly. Hold on here. Tablespoons of butter. 26 rolls for tablespoons of butter. That's a ratio. What we're trying to figure out is if we have 78 rolls, how many tablespoons of butter do we have or do we need? In other words, what we're trying to figure out here is when will this be a proportion? Now, when you're setting these up, what you have to make sure of is if you're going to have rolls on top here, you better have rolls on top there. In other words, the ratios need to be listed in the same order. And so here's what we're trying to figure out. When will this be a proportion? I'll let you take it from there. All right, Noemi, how many tablespoons of butter? 15 tablespoons of butter. Very good. If we go to this proportion that we have and we multiply top and bottom by 3, we will create the equivalent ratio that we need, which is 78 over 15. So that means we have 15 tablespoons of butter. We could scale up or figure out what number we need to multiply or divide by to make what we need. But regardless, we should end up with 15 tablespoons of butter. All right, go ahead and do 18, 19, and 20, and then we will compare all 3 of those with our shoulder partners. Number 18. If it takes 16 cups of sugar to make 36 brownies, how many brownies can be made with 8 cups? The given ratio is 16 cups of sugar for every 36 brownies. On my setup, I have cups on top of both of my ratios. That's the one thing that you have to make sure of when you're doing this. For some of you, it might be easier if you take the given ratio here, 16 over 36, and try and reduce that Obviously, you don't need to, but in some problems it may make these solutions, or the way to find a solution, a little bit easier for you. But regardless, we should get 18 brownies for that one. And I just went through all the methods there that we have talked about today. Scaling down, scaling back up, or by dividing both top and bottom by a number. Number 19, setup should look like this. 6 over 5 equals some variable over 25. I've got boxes on top of both my ratios, minutes on the bottom. Once again, on these word problems, we have to make sure of that. But regardless of that, there should be 30 boxes, and I don't know why it keeps going back to the beginning there. There we go. 30 boxes. And then number 20, setup should look like this. 12 cups of flour to make 108 cookies. 3 cups of flour will make 27 cookies. Any questions? Yes?
On my paper says 12 cups.
Ah, okay. Yeah, I think I forgot to have you guys change that. So let's do that really quickly. If it was 12, that's why a couple of you were looking at it funny. If that was 12, then it would be 12 over 108 equals n over 12. So what would that make, what would that give us then? Would it come out even? Yes or no? Yes.
You said it has to be matching.
Oops, sorry about that. Sorry about that. 12 should be up here. There we go. So what would it be for this one then? Yeah, that one was pretty, that would be way too easy. So if it was 12 cups, then it would be 108 cookies. That's my fault. I forgot to tell you to change this to 3 cups. All right, we are finished for